Yeah, hello everyone. Welcome back. Can you turn on the videos if any of you can? Okay, thanks. Let me share the screen. All right. Okay. All right. Let us begin the class. So, okay. Before we begin, this is the last class of this lecture. Okay. Thanks for participating till now. And so in the next week, we'll have so we don't have any class next week, where the final exam will be a take-home exam, which will be given in the week of finals. All right. So again, this is the last class. We don't have a class next week. Okay, as per the schedule, right? And in the finals week, we'll release a take-home exam. We'll release a take-home exam as a final exam. Okay. Any questions on that? I'll make an announcement. We'll make an announcement on the exact date right after this class. Okay. Any questions on that? All right. Good. So let's begin. I think today's class will be pretty short, quick. So today's lecture will be on Unix shell, how Unix shell works. So basically, we'll talk about how the shell works, and hopefully this will be helpful for your assignment 5. Okay. All right. So so what does the computer do for us? Well, it runs programs, store data, communicate with other computers, and also interact with us. Right? Okay. Well, I'm beginning from the very beginning for the people, especially for the people who are not taking 209, right? So so the interaction means like the user tells the computer to run the program, store the data, or communicate with other computers. So how can we interact with the computer? Okay. Well, um, used to be rewiring in the old days, but it doesn't really actually manually rewiring the wires, rewiring or reconnecting the wires, but not anymore these days. And telepathy, of course, not. And speech, well, we know that we are able to make commands with our natural language, but not too much, right? One way is to one typical way to make a command to a computer to interact with the computer is to type in the command you want, and that's what you've been doing until all for the entire semester, right? Okay. Oops. So the shell is the program that initiates a command. So basically, when you type in the command, whatever command you type into your computer, shell is the first one that will see the command, right? So basically, you input your command line prompt commands into the shell. Then what shell does, So what shell does is that it understands your command, and then it passes, and then it processes, and then it passes your command to the computer, right? So that it can be executed, right? Or to be more specific, it passes your command to the operating system, right? Okay. So for example, if you type A, if you execute A dot out, then what shell will do is it will find try to find the file A dot out, and it loads, and then it tells the computer to load the A dot out, and then it tells the computer to execute A dot out, and then finally the shell results returns the result to the user. Okay, that's how it works in your shell. Okay, when you type in one prompt, when you type in something on your prompt, this is actually what happens under the hood, right? So shell is a pretty useful program. This itself, of course, is a program, right? And it's a program to run program, right? So shell is there to help you out, um, with the computer to understand your command. Okay. So so it receives a string that contains, from a more technical point of view, in more technical terminologies, the shell receives the string that contains the command from the user, interprets the string, okay, and it lets the computer work on initiating the command that the user requested. All right, and don't worry if it's not really clear at this moment. It will be soon, at the end of as we move along. All right, and within this class. Okay, of course, a lot of people use GUI as well, right? GUI, which is short for graphic user interface. I guess most of us, including myself, use GUI more than a command line interface. But so what is the difference? So why do we use GUI more often these days? It's because it's easier to use, right? Okay, then you might have a question of why don't we use GUI in our class, right? Because there are limitations to GUI, right? Although it's very easy to use, right? We cannot do a lot of we can do a lot more things in command line prompt. Okay, like combining processes and adjusting I/O with pipe and redirection, right? Which we briefly talked about, which we have begin talking about in the, well, let's say we have talked about what we have talked about in EE 209, right? Okay, if you're not taking EE 209, don't worry about it. Okay, so it's hard to use, but it has its own benefits, right? Okay. For example, GUI, another limitation of GUI is that, for example, it has a limitation to use some programs like Make or Server Manager program, because GUI has a limitation of, inputting options, right? When you double click a program, it doesn't let you to input any options, right? Right? So of course, there are ways to input options in GUI as well. If you by using there is a interface for that in GUI as well, but typically, right, it's harder to use those options in GUI, right? All right, so here we'll talk about this is the very simple shell of code that we'll discuss about in this lecture. Okay, so of course the shell is much more complicated than this, but this is a very simplified version. This is actually an oversimplified version, so we call it a very simple pseudocode of a shell. Okay, so consists of like 6 parts. First, it gets the command from the user, and it delimit the command by spacebar and compose the argument array. Meaning, well, delimiting meaning it's actually dissecting, cutting the command into smaller pieces, right? So, for example, if you do ls minus a, right? What you have to do, okay, let me put it here. Here, ls minus a. Then what you have to do is we have to cut this into 2 pieces, right? Okay. And this is called delimiting, right? And this is divide by space, right? So we delimit or we dissect command into smaller pieces. And of course, we compose an argument array. If we might have 1 or more arguments, we store that in the argument buffer, right? Okay, that's what we do. And then, so up until here, we know we know the command, right? We know what program to execute, with which option, right? Okay. Now at this point, we're now ready to actually execute the program, right? And what we do is we fork the child process. Okay, you probably is aware of this if you're taking 209, right? If you're not, don't worry about it. We'll get to that point. And then the next step, the parent process waits for the exit of the child. Of course, again, you understand this if you're taking 209, but if you don't worry about it. We'll get to that point. And the child exchanges execution image to ls. Okay, the child changes itself to ls. Okay, all right, let's move on. So that's the big process. Okay, so and then what do? We go back to the beginning. Okay, that's the basic workflow of a shell. All right, it doesn't matter how complicated the shell is. It all follows this process. Okay, gets the command, it interprets the command, and then it forks, and then executes the program while the parents waits. Right, that's the whole story of the shell. Okay, and that's where you start from in assignment 5 for EE209. Right. Okay, and you'll be adding some functionalities on top of that. Okay. Okay, let's assume that the user typed this. Okay, so this is a program, and this will all be the taken as an argument. Okay, and note that this simple shell that we talked about in the previous slide has some limitations. So it executes 1 command, so it's not able to execute multiple programs, like using pipe, for instance. So it's not able to use pipes. Okay, and the user can only type 2,000 characters in a maximum at max, because we're actually having 2,000 buffer, 2,000 our buffer to take the command. It has a size of 2,000 characters. And it can have only 10 options at max, because we're using 10 array of 10 character pointers as arguments, right? Okay, and cannot change directory. It does not have environment variables such as path. Meaning, we'll talk more about this in the following slide, but you are able to, when you execute another program from a shell, you are able to, that program can have its own it can have its own environment variable, right? This path is the environment variable that we are aware of, right? Just like path, we are able to, when you execute a program, we are able to, that program can have its own environment variable. However, in this shell, we're not allowing that. And we'll talk more about that. And we'll talk more about why that is so soon, okay? Okay, so the users have to specify the full path of the program, such as like this, and not just echo. But in this lecture, for the ease of understanding, so without the environment variables, by default, we should put the entire path. Okay. Okay. However, in this lecture, for the ease of understanding, for simplicity, we are using this function specifically with with a P option. This P means path, and by using this function with P options here, right, we don't have to specify the entire path. Okay, all right, because this automatically finds a binary under the global system environment of path. Okay, so by using these functions, we are able to use the system environment of path. Okay, so therefore we don't have to put this full. We don't have to put the full path. Okay, let me repeat. Maybe this, I don't want to confuse you, so let me just repeat one more time. Okay. Okay. All right. All right. Well, let me come back to this if we need, I'll try to explain this in the later slide again. I think that's more efficient. Okay. I might come back here if I need to explain this once more. But anyway, I'll clarify this out. Okay, if this is confusing for you at this point. Okay, so it doesn't support pipe or redirection. Okay, the functions that we are using in this simple shell are as follows. Okay, and let's let's explain. Let's go through the functions one by one. Okay, let me get a drink. All right. Whew, okay. First, we'll use fgetString. Fgets, because this is to get input from user. All right. Okay. So so what this is doing is that it reads at most size -1, okay, characters from this stream and stores it into a buffer pointed by this argument. Okay. So you've been using a scanf until now, right? A lot. So let me show you the difference here. Why are we using fgets instead of scanf? Because scanf cannot read string containing a space. Okay, but we need to, right? For example, if you do ls -a, we have space here, but we want to read the entire thing, right? The entire string. Therefore, instead of scanf, we're using fgets. Okay, and the null is stored after the last character in the buffer, and it returns s on the success. Returns s, meaning so it returns s, which is here, right? Which is the address address where the string was stored, and null on fail. Okay. This fails when no characters are read. Okay. Good. So for example, how do we get input from the keyboard, which is standard in? So we put a standard in for the file stream, right? And we put the size of the buffer and the buffer pointer here, okay? Which is the name of this array here. Okay. Name of the array is a pointer, right? Okay, let's move on. The next, so given this, so with this function, we are able to read the command from the user, right? Get the command from the user. So from this workflow, after getting the command, what is the next thing to do? Is to interpret the command, right? Okay, so let's interpret the command. The first thing we need to do, as I told you before, is to dissect the command into smaller pieces, right? All right. How we do that is we use a function called string token. And this is how it looks like. And this actually breaks the string pointer, a string pointed by the string pointer here, into a sequence of 0 or more non-empty tokens based on the string pointed by delimiter. Okay, this probably doesn't make sense, but let's look at an example here. It'll make sense when you look at example. Okay. Suppose this is the so this is the so suppose this is the string, right? And if you want to cut the string into words here, where we have spaces in between. Okay, and in order to get the first word, this is what we do. Okay, we put the target string here, and we put the delimiter, which is the space. Okay, so what this is saying, is that use another color here. So what this is saying is that cut the string, cut the str with a space. Okay, so whenever you see a space, you cut the string, right? So by running this function for once, you get the pointer to the pointer to the pointer to the first token, which is hello. Okay. Okay. And the next call is different. Next call, you just put a null pointer as a first argument, and again, you put a delimiter, and this returns the pointer to the next token. Okay. Here, the token means the word. Okay. All right. But depending on what you put here as a delimiter, right? This doesn't have to be a token, right? Right? You can actually cut this into, you can actually use a delimiter of character A, for instance, right? Then you'll be able to cut this into, into different pieces, right? Okay. Hopefully that makes sense. Okay. And so this is what we just talked about. So it returns a pointer to the next token, or null if there's no more tokens. Okay. And let's move on to fork, right? So that was it for string token. So here, up until here, we are able to interpret the command. Here, we store the command. We get the command from the user. Here, we interpret the command. Now, what is the next thing to do? The next step is to execute the program, right? Okay. So the first thing that is done is the first step is to use the fork function. The first step is to call fork function. Okay? Fork is a function that is a system call that creates a new process by duplicating the calling process. Okay. For those of you who are taking 209, you're probably familiar. But if you're not taking 209, right? For the people who are not taking 209, what this means is that, okay, your shell, so you're running your shell right now, right? And your shell is to execute some shell wants to, if the shell is running, and if you want to, if you type in ls minus, so let's remove a here. If you type in ls, you want ls to execute, right? Okay. So but under the hood, what really happens is that, so we have a shell. If you type in ls, it will do a fork, and it will make a duplicated duplicate shell here. Okay, and this is the parent, which is the original shell, and this is the called child. Okay, so when fork is called, the shell duplicates itself and make a child, and then another system call called exec is called, and where this after the ls, the duplicate shell will change itself to ls program, and the ls is run. Okay. All right. So this whole thing is what happens when you type in ls, right, on your command prompt. Does it make sense? So here, in this page, we're talking about the fork here. Okay. Okay. Hopefully this makes sense. Right? So the fork returns 0 to the child. So it returns something called PID, right? It's short for process ID. The value is PID of the returned PID is 0 to the child, and the PID of a child, or for a parent, the returned PID is the PID of the child. So this becomes more clear if you look at this example here. Okay, you run fork. Okay, and this return value of PID, if it's 0, so at this point when you run fork, you have 2 processes now, right? One parent and one child, and you need to only the child should run execute, should call exec function, right? Therefore, we have to know if itself is a child or parent, right? How do we know if itself is a child? You look at the PID, which is the return value of the fork. If it's 0, it's a child. Okay. if it's not 0, or PID of it is equal to let me just use this. Okay, it's equal to child process ID, but not equal to 0, right? Then this means that it's a parent, right? So the so only if itself is a child, it will call exec to change itself to ls. Okay. All right. Now at this point, the shell is duplicated by fork. Then, and we know if myself is if myself is a child or if myself is a parent. So what do we do at this point? We have to, if we are a child, we have to run exec, right? Okay, this is what exactly happens. Oh, sorry. Let's move to here. Okay, this is a variant of exec function. Okay, so there are many different types of exec functions where we'll be using this one. Okay, it's here. So which takes a file which takes these arguments. Okay, and let's see one by one. So this executes the program pointed by a file name. Okay, here, with an argument in the argv. Okay, so ls will be here and -a will be here. Okay, and if you're using, if you're using exec VPE with an E option, with an E feature, meaning that it's able to take compared to exec VP, exec VPE takes additional argument called environment P. Okay, this is, if you remember, this is the local, not local. This is the environment. This is the, how should I say it? This is the environment variable for this process. Okay, do you remember? Let me go back and we talked about this, right? We said we don't have the environment in our simple shell program. We do not have the environment variables. We do not have a environment variable, right? Okay. And why this is so? Because we're actually using exec VP. Okay. So we are using exec VP, and not exec VPE. As you can see, exec VPE is able to take its own environment variable, where exec VP cannot, right? Therefore, in our shell program, since we're using exec VP and not exec VPE, our shell program cannot take its own environment variable, right? Okay. All right. So it returns error code on fail, and it does not return on success. Okay. Why does not return? Because we have already moved on to ls and we don't return, right? If exec is successful, meaning that the child has turned to ls now, so it never returns. If it returns, that means it failed to run exec, right? It failed to change itself to ls, right? In those case, we return with an error code. Okay. Okay. So when does it happen? When does a fail happen? Well, one example where the fail happens is if you try to run some program that does not exist, right? Okay. Fails when program does not exist, right? Right. Okay. So how do you execute a program? And this is an example, right? Okay. So we're almost there. So let's look at the simple pseudocode of the shell. Yes, and let's see how this is the same code that we've looked before, and now we'll go through the code line by line. Okay. Since we know the functions now, right? Okay. So first we run fgets, and this is what happened. Then so it reads the string from the standard in and save it to command array of characters. And we assume that we have typed this. We have typed this echo hello quasi shell. Okay. And the buffer after running this fgets, the result of a command buffer is like this. Is like below, right? So we have echo hello quasi and space in between, right? And quasi shell that ends with a new line, right? Okay. And we assume all the other characters are initialized to 0. Okay. Okay, let's move on to the next line here, right? Where we put 0 to the last character, right? Okay. So the character, by running this, of course, the last character, which is a new line, right, is removed and replaced with 0. Okay, the value of 0, integer value of 0, right? So that's actually okay, the integer value 0, not character value 0. Character 0, right? Okay. Okay, and yeah, and this is how it looks like after this, right? Okay, pretty straightforward. And then we run a string token with the delimiter of space. Okay, then what happens? It delimits the command by space and returns the start address of the delimited string. Okay, all right. So basically, it finds the first space, which is here, and replaces it with the value 0. Okay, right? Null character, right? And then it returns and saves. It returns, and in the token, it saves the position where. Oh no, this is not it. Okay, let me explain this a little bit later. Let me first explain the token. Then the token points at the beginning of the delimited string, which is echo. Okay, in this when we first run the string token. Okay, does it make sense? Okay, all right. So another important thing to note here is that string token saves the position where it's scanned in the static variable. So when we run this string token for the first time, when we run we should be able to run. So we need to get ready to run it for the second time, right? We'll run this string token again, we'll call the string token function again in order to get the second delimited string, right? Right? We want to do that. So we have to store, then that means we have to know where we left off, right? Okay, and this is what we do. We save this function, string token, save the position where we should resume when the string token is called again next time, right? Okay. And then it locates the new buffer and copies the content of the delimited argument in the buffer. Okay, so basically put the token which is pointing at the first delimited string and store it into the character pointer, which is pointing at arguments, right? So meaning you're actually storing the echo as the first argument, right? Or 0th argument, right? Okay, and we do it over and over again, and we jump into 4 because this is a loop function, because we don't know how many options we'll have, right? Okay. All right. So for every option, we'll try to we run the string token again. Note that we need to put null to indicate that this is actually a second call, right? Or a second or third call, not the first call of a string token. Again, the delimiter is again the string, again the space. Then what happens in the first for loop is that, okay, the next space will be replaced by a null character. Okay. All right, and the token, the new token will be pointing at hello now. Sorry for this. Okay. All right. All right. Okay. And now this part will be saved. Okay, just like here. Right? When we first called the string token, this position was saved in a static variable, right? When it's called second time, we start from there, right? Does it make sense? So when we first call the string token, this is the point where we saved in the static variable. When we call the string token for the second time, which is here, we start from here, which is saved in the static variable, and then move right to find the next space, and then change it into a null character, right? And we move the token to point at the next delimited string. And we also, lastly, we save the static variable to the next point to resume. Okay, and so on and so forth. All right. I've already explained this. Okay, and of course, for every loop, we'll have to store the argument in the store the argument, right? Okay, right. And when the token is null, we break, meaning token is null, meaning there's no more function, there's no more arguments. Okay. Okay. After we're all done, we put a null pointer, okay, at the end of the argument. Okay. All right. With this, And then we are up until here we successfully have interpreted the command, right? Now we have to move on to fork, right? Fork again creates a child process, and the child process starts executing the code inside of fork, and the fork returns the value of the return value of fork is different between parent and child processes, and we've talked about this already. Okay. If PID is not null, meaning this is a parent, we just wait. Oh, I forgot to talk about wait function, right? So wait function, I skipped this at the point. I wanted to come back, but I forgot to come back, right? So what is the wait function doing? Okay. So what wait function is, so if you're a child, you need to, so if you're a child, right, you need to do exec, right? After fork, if you're a child, if yourself is a child, you need to do exec to change yourself to ls. What if you're a parent, right? If you're a parent, you wait. Okay. Wait until what? Wait until your child terminates. Okay. And this is the wait function. Okay. So it sleeps until the state of the child is changed and stores the change in the wait status. Usually, it is used to wait until the state of child is changed to exited, meaning terminated. And if we put null here, it just returns without storing the change state. So if you put this something, if you put something and which is not null, if you put a W status here, then this P wait will store the changed state within as a code in W status. So this can be used, for instance, well, if you want to know how your child has terminated. So what signal, what was the exception that that terminated your child? If you want to know that, for example, if you want to know if a user typed in Control-C to terminate your child program, you can actually know that by using W status. That code will be stored in W status. But in our example, we're just putting null for simplicity. So we don't want to check. So we don't want to check how your child has terminated. Okay. All right. So again, parent waits until the child process exits. Okay, so if it's a parent, you run a wait. As you can see, you're putting null, right? We did not put W status, right? Meaning we don't want to track what happened to the child. We don't want to know how the child terminated. Okay, it's a bad parent. Okay. Anyway, so if you're else, meaning you're a child, then what do you have to do? You have to change yourself. The child has to change itself to the program, right? So it will run execvp. Okay. Right. Again, we're not running exec VPE, right? Okay. So we're just running execvp. Okay. For simplicity. Okay. Meaning that we're not taking its own environment variables. Okay. So the child process executes a program that the command it requests. So inside VP, the child process starts to execute the code from main function of the program that corresponds to argument 0, right? For example, this can be ls. Okay. So exact VP does not return unless exact VP fails. When does it fail? If the program does not exist, right? Okay. All right, that's it. So that's it for today, and this is the homework. Okay. So what is the homework? So we start from this. It's simple as always, right? So you start from this example shell code. Okay. And you need to do you need to add some functionalities. Right? You need to make the shell execute the command multiple times. So you have to make it a loop. Okay. And so you need to make a loop, and you need to make the shell get exited when the user types exit. And also you need to add appropriate error handling. For example, in this code is not checking if the f gets returns a value, right? F gets, oh sorry, if the it does not check, this code does not check the return value of the f gets, right? Here, f gets, where's f gets here? Right? Okay. So what if no, there can be an error in f gets, right? Meaning maybe there's no input at all. Then what happens? Right? Then f gets. So f gets will return here. I need to come back here. So it returns null when it fails, right? Okay, remember that. So what the homework is saying is that you need to handle this. You need to handle the case where the null happens, right? Null returns, meaning no character has been read. Okay. So how do you check this in your command line prompt? Is to type Control D, which is EOF. Without inputting anything, just press Control D. This means EOF, meaning you have reached EOF end of file, right? Then no character will be read by the fgets. Okay. And we have to do another error handling here, which is which is the case where exact VP returns. Exact VP should not return if successfully called, right? However, it may fail. If it fails, it returns. When does it fail? I've talked about this already, right? So when does it fail? When program does not exist. Okay. Okay. Does it make sense? Okay. Does it make sense? Okay, I think that's yeah, so that's it for today. So this was a short lecture. So that was not only for today, but that was actually it for the semester. Okay. So of course, if you have questions, you can stay as always, right? I'll be here to answer your questions. But if you don't, If you don't have any questions, you're free to go. I just want to say that before you go, I just want to say thank you for paying attention and trying hard. There has been a lot of homeworks every week, right? We appreciate your effort. This is just one credit course, and which is designed to be easy. Although there are a lot of homeworks, but it's designed to be easy, and it was designed not to give you more burden, but to actually help you out with your with your EE 209, right? Hopefully, you had fun, and hopefully this had been helpful, and not too much a burden throughout your lecture. And of course, the techniques that you have learned in this lecture, just like the techniques that you have learned in 209, EE 209, will be helpful throughout your career, right? Like using Gits, you'll be using Gits all the time, right? Once you become a software engineer, right? And writing make files, that will definitely help you out in your career, right? So those are the, not the well, not very complicated things, but those are the pieces that will be helpful throughout your career if you're doing anything in software, right? And the chance is that you'll be doing something, at least something in software, right? Even if you're not software engineer, right? Okay. So okay, so that's it. So that's it for this semester. Thank you all, and hopefully you find the finals easy enough. Okay, you can still contact me through or Professor Yun through emails and of course through Campus Wire. Okay, so if you have any questions, just let us know. Okay, and thank you all again. And I was happy to have you guys here. And hopefully you enjoy this course as well, as much as I did. And hopefully you have a great, enjoyable, and healthy winter break. Thank you so much. And there's actually a question. In the assignment page, when error happens, should you exit with the appropriate error message? Well, that is a good question. Well, that is up to you. Okay. As long as you handle the error, you're fine. Okay. So just handle it such that you think is appropriate. All right. But you have to capture the error, right? Right. Okay. So you're free. Okay. You're free to do whatever you want, but just make sure that you are actually catching the error. Okay. Thank you so much. And I hope it was a online lecture, but hopefully in the near future I'll be able to see you guys in person. Okay, thank you so much. Have a wonderful break. Bye-bye. I'm still here to take questions. Okay, bye-bye. Thank you. I'll mute myself, but I'm still here. So if you have any questions, I'll be here to answer. Thanks. I guess there are no other questions, so I'll end it here today. Thank you all. Bye-bye.